Hello everyone. In this video, we will introduce another type of improper integrals. These are the ones that integrand has a discontinuity in the interval of integration. Well, quickly recall that an improper integral, when we say we have an improper integral, what we mean is it is either an integral with infinite interval, which were like we discussed these ones in other videos, or something like this. Yes, so upper infinity or lower negative infinity, or both of them infinity. But then there's another case that the interval is closed, like from a number to another number, discontinuous integrand. So the integrand, the interval of integration is a closed interval from a to b, but the function or the integrand has discontinuity at these points. So either it has discontinuous at a from the right, or it is discontinuous at b from the left, or it's continuous on everything, but there is a midpoint, so it's discontinuous at c inside the interval ab. There is a point at which the function is discontinuous. So in this video, we will do this once, and there will be another video for the last case. Let's see what we do for these cases as we go through this example. So here, the function we have is 1 over root 3 minus x. And it is defined only on, well, from negative infinity to 3. But at 3, it is not defined. So it is discontinuous at 3, yes? Then what we do in this case. So let's just see what is the sketch of this function. This function, we know that at 3, so let me just, at 3, it has a vertical asymptote. And then, well, this goes like something like this. Okay, now we want to integrate from 0 to 3 to up to 3. I don't know how to do that part, but if I push this thing a little bit to the left, so I go a little bit lower than 3, then I can integrate the integral or the function on the interval 0 to that point. Well, it doesn't matter how small is that. For any t less than 3, this will be a well-defined integral. Okay, and well, in other words, I can go from 0 to t 1 over root 3 minus x dx by an easy simple substitution, u equal to 3 minus x. You will figure out that this is minus 2 root 3 minus x, and then you go from 0 to t, and that will give us negative 2 3 minus t minus negative 2 root 3 minus 0. Okay, so for any t it is defined, but remember the slogan: improper integral is not just an integral, it is an integral and a limit. Now, after knowing that for every t less than 3, what will be our integral? Now we let t go to 3 from the left. So that way we can find what will be the value of this thing. So t goes to 3 from the left. Okay, so this is And then when you do that, well, this is just a simple limit. So this will give us negative 2 root, well, 0, a little bit bigger than 0. So, I mean, positive number which gets closer to 0, and then 2 root 3, which will give us 2 root 3. And this way, we have made sense of integral from 0 to 3 of this integral. And in general, we will define this function or this such integrals by similar limits and integrals. So if f is continuous at on the whole interval a to b open, and this continues at 3, while here, well, if it is defined at b, then what we mean by discontinuity here is from the left. Okay, then by integral a to b f of x, which as a regular integral is not well defined thing, now we are going to define this. If you go from 0 to t first, then find limit of t as t goes to b from the left. And well, if f is continuous on the interval open a closed b and discontinuous at 2, if it is defined at 2, we mean from at a, sorry, not 2, from the right. So if it is defined at a, so we mean the discontinuity from the right, then we define this thing. Note that this is not a regular integral. As an integral and a limit. So if the limit exists, then we say the integral is convergent. Otherwise, it is divergent. So based on what we did, well, the limit exists, so this integral that we have is convergent, and it has actually the value 2 root 3. Okay. Well, let's do another example here in integral from 0 to 1 of f of x ln x. So our function is x ln x, defined only on the interval open 0 to 1, and not defined, well, actually it is defined up to plus infinity. Well, and that's enough for us, because now we know that up to 1 it is defined at 1 but not at 0. So it is an improper integral. So the integral is an improper integral. It's not a regular integral. An improper integral means that you have to have one integral and one limit. Okay, how do we do this? So let's just first see what is antiderivative of x ln x. Here, if you set u to be ln x and dv to be x, what you will x dx, what you will find, this is integration by parts, is that this is x squared over 2 ln x minus integral of x squared over 2 1 over x dx. x. And this is x squared over 2 ln x minus, this is x over 2, so this will be x squared over 4. That's the integral. Now, I don't want to go up to 0. I want to get close to 0. So that will give me this. And t. So what we found here is that now t to 1 x ln x dx is, let me just evaluate that. If I plug in 1, ln 1 is 0, so the first term will be 0, and 1 over 4 will be what we'll get there, minus t squared over 2 ln t minus t squared over 4. Now we want to find the limit of this guy as t goes to 0 plus. So I'll go right here and find the limit of this t goes to 0 from the right. Yes. So this way, if I look at this value here, if I plug in that one, this will give me 0. There is a negative 1 over 4 at the beginning. The only term that I have to be careful is this term here, as t goes to 0 plus. So let's see how is that, guys. So I will just do t squared ln t. I don't need to have that half there. I will add it there later. T squared as t goes to 0 is 0, but ln t as t goes to 0 is negative infinity. So this is 0 times negative infinity. To get this thing in a form that I can apply substitution, I will change one of these functions here, t squared, to 1 over t squared. And that way we will get negative infinity over infinity, and we will be allowed to use L'Hopital. And L'Hopital tells me that this is 1 over t negative 2 over t to the power 3 as t goes to 0 plus. And this is the same thing as t squared over negative 2 as t goes to 0 plus, which is equal to 0. So this part also is going to give me 0. So my integral is going to be negative 1 over 4 plus 0. So that's the value. And remember, you cannot go ahead and plug in zeros. At 0, ln t is not defined. Look at here. You have to make it to an integral and the limit. And then the limit, when you find, that will give you what you were looking for. So that's what is called improper integral with discontinuous integrand. Well, we will have another video when the discontinuity is in a midpoint of the interval of integration.